Hello everyone, in this session we'll be looking at the survey drafting techniques. Simply, these techniques will make our step number one into road design. As you can see here, the procedure for engineering drawings for rural roads. Rural roads, as we agreed, are the roads designed to account for vehicles with relatively higher speed comparing to urban areas. In order to design these roads, first of all, as we agreed, we had to set some parameters. We had to set the basics, the foundations for the road design. We have to learn the terminology. We have to learn the language for the road design. In order to do that, and so I can simplify the process rather than going into too much information, as you would see in a minute, I'll be going into some theoretical information. In order for us to understand this theoretical or the need, the importance of this theoretical information, I'll be starting by a very simple practical design of a road design, an overall view for the methodology and the steps that we usually take into road design to give you a brief idea where we're heading with this and what is the need for all this theoretical information that we should learn and we need to learn in order to complete a road design in a successful way. So I'll be using a very simple software that you all are familiar with. Sketchup. So this is just, as I said, illustration only. That won't be part of your engineering design. That won't be part of your examination or the course. Just for you to understand, that will give you a very practical view of the road design. Okay, that will show you what is the actual software Civil 3D will be using for road design. What is the software doing behind the scenes? Okay. So in order to design a road, to start with what you are looking at here, you're looking at a ground view. Okay, so looking at a plan view of an existing ground. Let's say this is the view of this area here, for example. Okay, so let's take this area here. So as if we're looking at this portion of the land. Okay, I colored it in green just to illustrate the grass, as you can see, just for illustration. Now, as you would appreciate, in each ground parameters that you've got the elevations of the ground or the topography of the ground. There's no flat ground. So if we look in a more realistic view, if we have a more realistic view into this ground, that's what we'll be seeing. So looking at the ground in 3D, you start seeing some topography. It won't be flat as you would see it from the top, as what we can see from here. So there's no such flat ground. That's number one. I will talk to you later on about that topography, how the software illustrates that topography later on or understands that topography. Again, it's important to us. We'll understand why when we study the rectangular coordinates, northing and easting and elevation for points. We will talk about it a bit later in this video. Looking at the ground from the top, if we look at any existing road, what we can illustrate that road as if this road is a one line, that line there. Okay, a curve. Sorry, I will not call it a line. It's a curve. This curve, realistically, you will learn later on during this course. Any road, we look at it as a group of curves connected with straight lines. So if I zoom out, I can see this road is made of a group of curves connected with each other with straight lines. Okay, for example, I've got this curve here, that curve there, in between them I've got that straight line. That straight line you will learn later on that we call it tangents. This is the tangent part of the road, alignments. Before we get into details, step number one. The line of the road or the curve of that road here, what we can see from the plan view or the aerial view, we call it horizontal alignment. So this is the first technical term that we have to keep in mind. So when we say the horizontal alignment, always imagine that you are looking at the road from a map view, from Google Maps. Okay? So as you can appreciate here, looking at that view, it doesn't take into account any details for the elevations, for the height, for the ground. All what we see is just flat ground with line. lines on it. These lines, they're representing the roads. So the horizontal alignment doesn't take into account anything vertical. It's called horizontal alignment. So let's have a quick look at horizontal alignments. This is a horizontal alignment for that road, for example. So when we draw it later on a software, you'll see just a group of lines connected, group of curves. Preferably, we call it group of curves. If you look at that, this is a curve, another curve connected with straight lines. This is what we call it. This is another example of horizontal alignment of a road. Okay, this is the technical term for it. Along this line or curve or group of lines and curves, the alignment, horizontal alignment, any point along this horizontal alignment has a geometry length from the starting point. We call them chainages or stations. Let's start with stations. This is a bit more realistic naming. Stations or chainages, simply you learn later on, that defines the location of that point along this alignment. So this will be station number 0. This could be station 100. This could be station 150, 175. There is obviously station 75, 80 along the entire length of the horizontal alignment. We will talk about those later on. So keep in mind, if I look at a road from the top, seeing the horizontal alignment, all what we care about then is the location of that road or the curvature of that road within a plane, within just a one horizontal plane, without worrying about the elevation. We don't see all these elevations. All what we see, the curves. If that's the case, I'll go back to our SketchUp. Now you know when I say I've got a land or ground surface, that green part there, and I've got a curve here or a line represents the horizontal alignment. We've got two components of the road. So how does the software work for road design? Number one, or step number one, we have to show the software where do we want our horizontal alignment. So we are asking the software for Civil 3D. Later on, I'll do this exact example on Civil 3D, so you see how the software will represent all this information, obviously in much more accurate way compared to what we're doing here. What we're doing here shows a bit more practical steps how to do it. So step number one is to enter or draw on the software our horizontal alignment. The minute we draw our horizontal alignment, then what we have to make the software understand is the profile of that road. In other words, let's have a look. What is a road profile? A road profile is the vertical view of that road. Now, without worrying at all about the horizontal alignment or about the horizontal curvature. In other words, let's have a quick look here. So that's another view of vertical profile. These are the chainages. When I was talking about the chainages a minute ago, these are representing, for example, along this road, each distance has a number in meters, and these what we call them changes or stations. So for example, this is a horizontal alignment here. This horizontal alignment, each one of those showing a change or station, what we called it, along the horizontal alignment. Going back to the road profile, what I was talking about, the vertical profile, which is second step after we specify the horizontal alignment, we have to go back to a road profile. So let's have a quick look. What is a road profile? Road profile, this is the road profile. Let's assume I've got a small portion of a road here, okay? We're trying to break down that road into a few different components, into a few different steps. Step number one, what we call about it, the path of the roadway, or what we call it, the horizontal alignment, shows the curvature of the road horizontally. Step number two is the road vertical profile, shows the height of that road, purely the height without worrying. Look at it, it's drawn on a straight line without worrying the horizontal curvature. So purely going from one point to another on the vertical profile, on the horizontal profile, sorry, here, measuring the height there without worrying about anything else and plotting it on a vertical profile. This is very important information, as you would imagine. This shows us the height of the road, because if you look at the road from the top, of any road from the top, for example, if I'm looking at it from here, all what I see is a vertical, is a flat line. But reality, if we look into, let's go into here, for example, I'll show you another road. So let's have a quick look into here, for example. This is a straight line, as you would see. For that road is a straight line. But let's have a quick look at the road if we are driving on that road. As you can see, the road looks straight from this side here, but from that side it's not straight. It goes uphill and then downhill after. Well, this is very important for us, because when we design that road we need to understand this topography. Because, for example, the driver is driving along here. If we don't design this topography in a safe way, there's a big chance this driver here, he can't see another car coming in the other direction. For example, if we create a overtaking lane here with the road design, that will be the wrong location, because this driver can't see any cars coming in the other direction because of the vertical height, because of the height of the road or the vertical profile of the road. So this will be our step number 2 here into the road, is to understand the road vertical, the topography of the land. Step number 3 for the software, how does it work? Will ask us, okay, this is, now we understand the topography of the land. You drew the topography of the land, you drew the horizontal alignment. Number 3, please provide the cross section of the road. Now the road cross section is something important to us too. So for example, I'm looking at this road here. This is the type of road what we call the rural road or country roads. So I've got one lane going this way, another lane coming the opposite way. I've got this space here near the lane called shoulder. We'll learn later on what's the job for this portion here. And we've got that small portion outside the pavement here. We call it the verge of the road. Another portion there, we'll understand later on what's the job for that. So each road, it doesn't matter it's a country road or an urban road, has a cross section. Therefore, we have to enter this information also to the software. We have to tell the software what type of road we are trying to design. Are we designing a urban road like what you see here, or are we designing a country road? I'm not sure if I have any country. Both examples I've got here are urban roads, or a country road what you've seen here, which is made of 2 lanes, 2 shoulders and 2 verge space. Do not be concerned about the names and all of those. We will learn them later on during their own specific lectures. The important part for me here that we do understand now, that to design a road, number 1, we design the horizontal alignment. How does this road sit in a horizontal plane? Number 2, we have to understand the topography or the profile of the existing ground, which later on will create the topography of our road. Number 3, we have to understand the cross section. So what I've designed here, for example, a cross section made of 2 lanes and 2 shoulders, similar to the country road. So that's 1 lane, that's another lane, and these are the small components here are 2 shoulders. Notice that always the 2 lanes, they falling away from the center line. This point along that center line, we'll call it the crown. This is the crown of the road. We'll talk about it, the ridge or the crown, the highest point on the cross section. You can see it here. This is the crown point. The main reason for this, to drain the water off the road. One of the biggest enemy for the road is having the water goes under the pavement. So that will help to drain the water quickly from the road, which will help for the friction, for the cars driving, all of those safety requirements, as well as the structural integrity of the road for a longer term. Anyway, so we created cross section, we have horizontal alignment, we do understand the topography of the road. Let's ask the software. So that's what we'll be doing later on. We'll be asking software, okay, What you need to do, draw this cross section along this horizontal alignment along that vertical profile. This is what the software really doing behind the scenes, Civil 3D, when we start talking about the software later on. Therefore, we have to understand these components. So if I'll do it here in a basic way, for example, so I'll be just saying, okay, draw this cross section along this line, for example, and then along that line. So here, I'm just saying, draw it along this line here. So you understand, let me just see what I can do. So this is essentially what the software will be doing. So trying to ask, what is the cross section, and repeating and drawing this cross section again along this horizontal alignment. Now this is one thing I can't do here at once, which the software will be doing in Civil 3D, not just only along horizontal alignment, as well as will draw along a vertical profile. In this scenario here on Sketchup, because I don't have that capability on the software, I'm going to do it into 2 different steps. So I've done it now. As you can see, I drew, if I look at it from the top, the cross section along that horizontal alignment. So if I look at it from the top, that's what we see, the road on the ground. But until now, the road is still just a flat line sits above the ground, just for illustration. What I need to do now is just to copy that road into, so let me select these 2 surfaces first, this one and that one, and say, okay, copy that road into this surface here. We'll wait for a little bit till the software will do the job, this is one of the main reasons you will see later on. We don't use this software. It's too slow and not accurate comparing to what we'll be doing later on. But now, so you can see it. So in theory, that's what we'll be asking the software to do. So let me hide now the top components. I'll hide those. In theory, that's what we ask the software to do. Draw that surface on this height of the profile. So you can see in some areas the road will be higher than the existing ground. In some other areas the road will be lower than the existing ground. Obviously that looks straightforward in here. Having said that, you can tell there's no accuracy whatsoever. We have no numerical values of this design, what we created here. It's just for illustration. I found it's easier to illustrate the road design for you in this software rather than on Civil 3D. Civil 3D will be doing all these steps in more systematic way, more numerical values, more accurate numbers. Okay, one last thing before I move on to Civil 3D. I'll do a road design there for you quickly. I need to show you how does the software understand this topography or the ground. So let me just close this, save and close. If I open SketchUp again, something important for you to understand. What is a surface? And how does the software will understand that topography, what we've seen? So simply, if I draw a surface like that, that surface here, what you can see, if we look at the surface as an entire surface, can just move up or down as an entire surface without, this is moving up or down without any articulations, let's call it, okay? But rather than looking at a surface as an entire surface, what you can see here, for ground or for road, for anything like that, what will be from now on representing these surfaces in a group of points. So rather than looking at it as a surface, let's make that surface in a group of points next to each other. Now when you look at these group of points, for example looking at it here, I can just hide these points so you don't see them, but they are there. So if we look at those, they are there, already there. In fact, they're not group of points, just all the surfaces between them. The smallest geometry that we can create is a triangle, not a rectangle or a square. Therefore, keep in mind what the software will be represented in the what the surface will be represented in the software later on as a group of triangles next to each other. Think about it. If I have one point, that will create just a point, and I have 2 points, that will create a line. But if I have 3 points, that straight away will create a triangle, and that's the smallest surface that we can create. So it's simply the software will divide your surface, doesn't matter how large the surface is, into a group of triangles sitting next to each other. Why would we do that? Because that will give us larger freedom. For example, when I'm looking at this surface here, when I have these triangles next to each other, I can now move these points up or down, and that will create our topography. For example, so let's select all these groups, these points, for example, and move them up. And this is realistically what the software will be doing to create that surface. Obviously, as we agreed, we can soften, and that's what the software will do, soften these surfaces and hide all these triangulations. We call them triangulations, thin surface. That's what we call this surface, thin surface. So the software will hide them, so you can look at it as if, yeah, that's a ground geometry. As simple as that. Okay, so let's have a quick look now at this surface here. Let's go back, hide the bring us back the triangulations, and let's try to understand. So if you look at it from the top here, each one of these points has a value vertically, value horizontally, that's an x and y, and the third value is like for the height, which is x, y, and z. If you look at the axes we've got here, so one going in the x direction, let's assume this direction, that's y direction, and that will give us z direction. Having said that, we don't use in civil design x and y and z. Instead, what we use for those, later on you will learn them, north, east, and vertical height, z value. Okay, so that's just to make you understand how the software understand a surface. It's just a group of points next to each other. Each one of these points has 3 main parameters. On the x direction, let's call it the easting direction. On the y direction, we call it the northing direction, and a height from the datum, which will give us the z value. Okay, great. So this is, in theory, as we agreed, this is showing you what is the software trying to do to create a road design. But in the I'll do a quick video now. How do we do the actual road design on the proper software here? And now, since you understand the methodology behind it, but you see the accuracy with the software when it's doing the job. Okay, so I'll stop the video here. I'll start a new video just to show you the software.